Sony Xperia 5V camera test. Peace be upon you, my dear friends and followers of the channel. How are you today? I hope you are well and in good health. Today with you is a beautiful, new and important video for everyone. This video will be called the Sony Xperia 5V camera test. But before watching the video, subscribe to the channel and like and share so that it reaches the largest number of people. Now let's watch the video and I hope you like it. We put the Sony Xperia 5V through a battery of rigorous XMark camera tests to measure its performance in image and video quality and zoom from an end-user perspective. I will explain the device's performance in a variety of tests and several common use cases and aim to highlight the most important results of our tests through a snippet of the data captured. Overview. Main camera specifications. Primary camera, 48MP sensor, 1.12A micro pixels, 24mm equivalent f/1.9 lens, dual pixel DAF, OIS ultra-wide camera, 12MP sensor, 16mm equivalent f/2.2 lens, dual pixel DAF. Pros: good detail in most conditions. White balance is fairly accurate in bright, indoor lighting conditions. Subjects are well exposed in close-ups, even with backlighting. Cons: reliable autofocus but noticeable capture delay and high contrast scenes. The preview image is different from the final capture. Slow transition for white balance and video. Strong orange shade in low light videos. In our XMark camera tests, the Sony Xperia 5V showed improvements over its predecessor, the Xperia 4, in both the photo and video categories. However, the omission of a dedicated camera module in the latest model means that performance in the zoom category has actually declined compared to last year's device, and overall the Sony is nowhere near the top of our rankings. Still, images captured with the Xperia 5V showed good exposure in daylight and indoor conditions. Testers also liked the well-controlled noise but criticized the limited dynamic range when shooting high-contrast scenes. The video mode provided consistent autofocus and effective brightness management in bright light. However, as in photography mode, dynamic range was limited, and video noise was noticeable in all lighting conditions. Test summary about XMark camera tests. XMark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, in which a sophisticated set of metrics allows a group of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the XMark camera protocol. About XMark camera photo tests for recording and analysis. XMark engineers capture and evaluate more than 2,600 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings. The photo protocol is designed with key use cases in mind and is based on typical shooting scenarios, such as portrait, family, and landscape photography. Evaluation is performed by visually examining images against a reference of natural scenes, and by performing objective measurements on chart images taken in the laboratory under various lighting conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure and color are the main features of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors evaluated are contrast and dynamic range, for example the ability to provide visual detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Autofocus tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually taken. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field is pleasing for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as group photos. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of objects in images captured in the laboratory as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on chart images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are the Special Xmark (DMC) chart and the Dead Leaves chart. Noise tests analyze different noise attributes such as density, color, grain, and structure in real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also in dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The chart used is the Dead Leaves chart and the standardized measurement is visual noise derived from ISO 15739. The effects assessment addresses lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantization, and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and more frequent the effects are, the more points will be deducted from the score. Below is a list of the main effects observed and corresponding point loss. Preview tests analyze image quality in the camera app's preview of an image, paying particular attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zooming from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. About Xmark camera zoom tests. Xmark engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low light landscape scenes, using default camera settings and dial zooming at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by making objective measurements of histogram images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. These tests analyze the ultra-wide camera's performance at several focal lengths from 12 mm to 20 mm. All image quality attributes are evaluated, with special attention paid to such artifacts as chromatic aberrations, lens smoothness, and distortions. The images below are an excerpt of the scenes tested. All image quality attributes are evaluated at focal lengths from approximately 40 mm to 300 mm, with particular attention paid to texture and detail. The result is obtained from a number of objective measurements in the laboratory and perceptual analysis of real images. About Xmark camera video tests. Xmark engineers capture and evaluate more than 2.5 hours of video in controlled laboratory environments and in low-light landscape scenes, both indoors and outdoors, using default camera settings. The evaluation consists of visual inspection of naturalistic videos captured in various conditions and running objective measurements on videos of histograms recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. Exposure tests evaluate the brightness of the main subject and dynamic range, that is the ability to render visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Image quality analysis looks at color rendition, skin tone rendition, white balance, color shading, White balance stability and its adaptation when light changes. Texture tests analyze the level of detail and texture of real-life videos as well as graphic videos recorded in the lab. Natural video recordings are evaluated visually, with special attention paid to the level of detail in bright areas as well as in the dark. Objective measurements are made of graphemes taken at various conditions from 1 to 1000 lux. The charts used are Xmark, DMC, chart and dead leaves chart. Noise tests analyze different noise attributes such as density, color, grain, structure and temporal aspects in real-life video recordings as well as videos of histograms captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on video clips of histograms recorded at various conditions from 1 to 1000 lux. The scheme used is the Xmark Visual Noise Chart. The stabilization rating tests the device's ability to stabilize footage thanks to software or hardware technologies such as OIS, eyes, or other means. The evaluation looks at residual motion, smoothness, built-in artifacts, and residual motion blur on walking and running use cases in different lighting conditions. The video below is an excerpt of one of the scenes tested. Artifacts are evaluated with MTF and ringing measurements on the SFR chart in the laboratory as well as frame rate measurements using the LED global timer. Natural videos are evaluated visually by paying special attention to artifacts such as aliasing, blocking, and skewing, among others. The more severe and more frequent, the higher the point deduction from the score. Major artifacts and corresponding point losses are listed at the end of the video. I thank you for watching and I hope you liked it, and see you in a new video.